Hey everybody, welcome back to the channel. Um, this is my first video of anything noteworthy that I want to talk about. I have made one more video where it just kind of introduces who I am, what I want to do with this channel, and the types of videos you might see. This is going to be the first video of this little mini-series reacting to this GovCon 7 presentation. GovCon is a conference for the government in the US where they kind of highlight new tech, new initiatives, things like that. And what we're going to be watching is a presentation from a Palantir forward deployed engineer. I think this is from around 2011. So basically what he'll do is kind of walk through how Palantir came about, its ethos, its roots in PayPal, and then kind of give a more breakdown of what they actually do, what are their functionalities, what Palantir is and what it's not. People often confuse them for things like being a cybersecurity company, a visualization company, a defense contractor, consulting company. So I kind of really want to just, with this video at least, show people how it's not any of those, and it's more of a operating system for any data issues, and it's the data hub for a new business, or any existing business, not a new business only. But yeah, I think shouldn't talk too much. I'll let him take the floor, and then I'll just jump in at little parts. I'll probably be breaking this video down because it's pretty long, and I don't want to make the videos too long. So yeah, let's just get into it.
Good morning, and welcome to GovCon 7. My name is Saad Abdali, and I'm a forward deployed engineer here at Palantir Technologies. And this is Palantir 101. So what I'd like to do is, over the course of the next half hour or 45 minutes, to talk to you a little bit about who we are, about what Palantir is and what it does for the organizations that we work with, and take some time at the end and give you a very quick product demonstration to give you a sense of what it is we're really talking about here. And so before I jump into all that, I'd really like to start this morning by telling you two stories that I think shed a lot of light on the way that we at Palantir think about the problem of analysis in a world of big data. And so the first story is actually a story about the game of chess. Now, most of you are probably aware that in 1997, IBM built a specialized chess supercomputer named Deep Blue, and that this computer went on to defeat Garry Kasparov, who was at the time the #1 ranked player in the world. Now, ever since then, I'm actually sorry to report things have not gotten much better for human beings in this battle. So nowadays, actually, it's very common to see cell phone software, so chess software running on a smartphone, competing and winning in tournament play. So the question of whether a computer, a really powerful computer, is better than a powerful human at chess is actually not that interesting anymore. Not as interesting as it was at the end of the 20th century. But recently, the chess community has started asking a different kind of question. Instead of pitting humans against computers, they've started to ask, what would happen if we allowed humans and computers to play together as a team? What would be the result? What kind of play would we see? And the results were actually very interesting when they did this and put it together. The first result was that the combination of a human player with the aid of a computer was extremely powerful. And maybe this is actually kind of expected, right? So we know that humans are really good at chess. We know that some computers are really, really good at chess. But we also know they're good at chess for different reasons. They have different strengths. And so the computer obviously has a huge tactical advantage, a computational advantage. A computer can calculate the value of tens of thousands of positions every single second. But a human can take a shortcut through those computations sometimes. A human has experience. A human has insight. The human can feel out his opponent in a way that's very hard for a computer to do. And so these strengths are complementary, and maybe we're not so surprised that the combination of a human and a computer can actually defeat the greatest human players and can also defeat the greatest chess supercomputers. But there was a second result here that's actually a little bit harder to explain. Because you might take a look at that first finding and you might say, okay, humans and computers are complementary, they play very well together. And as a result, let me take my single strongest human player and put at his disposal the single strongest chess computer, make them into a team, and they will dominate the tournament. You might think that, and you'd be wrong. Because it turned out that the team that won this tournament was not a particularly powerful player, it was a modestly skilled player. It was also not particularly powerful hardware or software. It was commercial-grade laptops running freely available open-source chess tools. And so what happened? How did this combination defeat teams that had stronger players and stronger computers? Well, it turned out there's sort of a hidden factor here, something we didn't consider, which is not just the individual strength of the machine, and not just the individual strength of the human, but the interface, the quality of the interface between the two. How easy is it for the human player to ask the questions that he needs to ask? Is it possible for him to focus on the things that he's really good at, the strategic oversight, the guidance, and to rely on the computer for those tactical components? And so this actually aligns very closely with the way that we at Palantir think about the problem of using computers, using the power of modern computing to assist organizations with the analysis of huge amounts of data. Everything we do focuses on reducing that friction, we call it, the friction between the player or the analyst who wants to use a computer to perform a task and the data or the computation that he wants to do with that computer. The second story I want to tell you is about a company you've probably heard of.
Yeah, so just want to pause there and just explain a bit more about what he's talking about. So far, he's introduced the concept of chess and this human-computer symbiosis. He hasn't exactly said that, but that's kind of what he's alluding to. And he's explained that the best chess player has been outdone by the best computer for some time, so that's not really a debate. But now what they're talking about is joining them together, the best human and the best computer, which is very powerful, but you would be wrong to think that that's optimal. And that there's this hidden element that people don't really consider, which is the quality of the interface between the human and computer. When that's good, that's what lets a team win. And this is because I think in professional chess, there are, and in the real world, there are constraints that you have to work with. You can't just work with unlimited time, unlimited resources. So if you aren't able to ask the computer questions efficiently, effectively, you lose just by default because you lose on time. So you basically have lost. So that's not a good thing. If the best chess player has to wait an hour to code his question into the computer to get an answer, but the game is a 10-minute game, you know, it's useless. And it might seem arbitrary, but in the real world, this is what we're always faced with. We're like always faced with these constraints. So sometimes it's a situation where you either get the decision right, or someone dies, or you lose a lot of money in a pension fund or something. So it matters. And just to help you really understand this concept, maybe I would relate this to that saying where the whole is greater than the sum of its parts, and the whole is better than what you would expect from the individual parts. So basically, when you find the right way to combine components, it adds a different quality or a different skill that is not seen in either of the base components. And the base components of a human being that it's good at taking shortcuts, it's good at learning from experience, and it's good at knowing what questions to ask, knows how to work with emotion, context, much better than the computer. But what a computer is good at is computational efficiency, really storing moves in memory, highlighting problems that have occurred in the past, things like that. So when you really put these two together, you almost create a new organism that can get you much superior outcomes. And that's kind of what he's saying, that Palantir is based on this idea and this ethos that a human and a computer together create greater outcomes. So yeah, that's just a little explanation for that in case you needed it. Let him continue with his next story.
Called PayPal. Had to get my clicker working there for a second. Now, at the time that PayPal was getting its start, there were several other companies also getting involved in the online payments industry. And these included some of the financial heavyweights. So Citibank had its online payment system. Western Union had an online payment system. This also included eBay, the internet giant of its day, which also had its own competing system. But in the end, all of these other competitors went away one by one. They folded. And it was PayPal, the startup, that succeeded where they had failed. It's a little bit hard to explain this. Why was this the case? Well, it turns out that to understand this, we have to understand one really fundamental fact about the business of online payments at that time, which is that it wasn't a business that had as its central challenge the task of moving money from one account to another. Because all the companies I mentioned were able to more or less do that, and to do it well. That's not what differentiated them. It turns out that the single most important challenge was to figure out how you can move money at scale from one place to another without getting fleeced by the Russian mob. It was really a problem of fraud. You had a huge number of transactions, a large volume of data coming in, and a very short amount of time with which you had to clear those transactions. Customers aren't going to wait a week for you to investigate every single payment. So what you need is the ability to quickly decide whether a given transaction or set of transactions is genuine or fraudulent. It's an analysis problem at its root. And so faced with this problem, PayPal and its competitors took two very different approaches. Most of PayPal's competitors took the approach that, okay, the problem that we have is that we have to make too many decisions very quickly. We don't have enough manpower to investigate these all with our human analysts. And so the answer is to offload this as much as possible into something that a computer can do in a way that's consistent, that's repeatable, and fast, right? Something algorithmic. This approach, it turned out, just wasn't good enough. PayPal was faced with the exact same problem, but they took kind of a different perspective. So they started at the same place. They said, we have a huge amount of decisions to make, huge number of decisions to make over a large amount of data, and we have to do it quickly. But they took the opposite perspective. They said, well, obviously, the answer is to increase the effectiveness of every human analyst, to put the computing power at the service of the human who's still making the ultimate call, who's still doing the analysis, who's still asking the analytical questions. And the focus is that everything we do on the computing side, everything we do is all about empowering that analyst to explore his data faster, to answer questions quickly, to discover the anomalies he needs to discover, and to make those decisions for the business. So eBay saw the writing on the wall. They had an exit strategy from this battle, which was to purchase PayPal for $1.5 billion. And after this happened, the team at PayPal became notorious in Silicon Valley as very, very prolific entrepreneurs. And some of the members of that team went on to found another company you may have heard of called Palantir. Because it turned out that the same exact problem that the fraud team faced at Palantir is applicable across many domains. Think about the world that they lived in. They lived in a world with a huge amount of data coming in at an increasing rate. And they lived in a world where very quickly they had to make good decisions based on fast analysis of that data. And this is applicable across a range of domains. This is true in law enforcement. It's true in the intelligence community. It's true in defense. It's true in public health, if you're tracking the outbreak of a disease. We live in a world with an increasing amount of data and an increasing need to use that data to drive good decisions. And that's what Palantir is all about.
Yeah, so again, just to explain a bit more, what he does here is actually make a very poignant distinction here, building off the human-computer symbiosis example. So what he's saying is that what PayPal did and why it was successful was that it took a very different approach to most of its competitors, which eventually folded, and the problem was solving how to handle many payments while also not being victims of fraud, so losing money to fraudulent transactions, to people laundering money, things like that. And it's important to note, again, like what I mentioned, that this is similar to the constraint in chess, where, yeah, you can just handle these payments, but if you can't handle it while stopping fraud, it's almost useless. You'll fold, you'll lose a lot of money. So you really need this problem solved. And what they did was, instead of algorithmically trying to find these fraudulent transactions, which in this case the Russian mob could easily circumvent, because once you code something, the hacker or the opposing side can easily just look at what is being done and then just kind of remodulate what they're trying to do, and then your machine learning algorithm or whatever can't pick it up because it's just trained to do that one thing. So what PayPal instead did was, I think, make like a system that just highlights these discrepancies using a lot of anomaly detection, things like that. But the main thing was highlighting the problems to the human analyst, who could then take actions. And And it's basically, rather than just solving the little task, which is that so instead of solving the task, they're finding the root cause of the problem. Um, and in this case, it's the literal person making these transactions. In a sense, if you're familiar with like in terms of software and engineering, it I think what they tried to do was basically solve the space-time complexity on a very aggregate level. So because you just have one system solving all your problems, rather than having a smaller solution to smaller problems. So instead of creating a model to stop phishing scams, another model to stop people who are accepting money but not sending a product, and maybe another model to stop high frequency transactions. These are all like band-aid solutions. The mob can just modulate the rate of transactions, for example. So if the machine learning algorithm is made to stop any transaction that's happening at like 5 transactions per minute, they can just modulate it to be at 4 transactions a minute. You know, they can just do simple things like that to fool these models, and then it basically, you just have to keep doing these models. And basically the problem with that anyway is that when a human looks at that and decides to make this model, they basically find out what the mob is doing. So why not just make your whole operation that you just highlight it to the human and then stop the root cause? So that's kind of where Palantir kind of starts from, their roots. I think I'll probably stop it there for this part, because it's a good like little chunk just talking about their history and where they come from. Later on, he will go into describe how Palantir uses this and has made this their foundation of how they've built their whole software offering, their whole product. So that's definitely there to look forward to. And just a little bit more about this video and like me is like, this was definitely the first video I saw that made me really think, holy crap, about Palantir. I saw the use case and I was like, this is applicable in so many domains, in so many cases, that I was just so interested to research it more, find out more. And yeah, that's kind of why I'm making this video today. I mean, I saw this 2 years ago. I've come back to it over time as I see the news from today and learn new things, and then come back to this and see all the principles that he's talking about, how they're in the product today. So yeah, I hope you enjoyed this video, this little breakdown for this Palantir history class, I guess. And definitely come back for more. I will be breaking down the full video into chunks, talking more about whatever he says. And there's also a live demo of the product at the end, so would definitely recommend sticking around. Peace.